RN Mastech play with graph. ഇവിടെ നമ്മൾ ഫംഗ്ഷനും അതിൻ്റെ ഗ്രാഫും അതിൻ്റെ ഒരു ഡീറ്റെയിൽഡ് എക്സ്പ്ലനേഷനാണ് നമ്മൾ ഈ ഒരു സീരീസ് ഓഫ് വീഡിയോസിൽ ചെയ്യുന്നത്. ഓക്കെ, ഫങ്ഷൻസ് നമ്മുടെ +1 +2 ഉള്ള ഒരു ടോപ്പിക്കാണ്. അതിൽ ഫംഗ്ഷനുണ്ട്, ഗ്രാഫുണ്ട്, ഡൊമൈൻ, റേഞ്ച്, ഇങ്ങനെയുള്ള ധാരാളം കാര്യങ്ങൾ ഫംഗ്ഷൻസുമായിട്ട് കണക്ട് ചെയ്തിട്ടുണ്ട്. അതിൽ നമ്മൾ കോമ്പറ്റേറ്റീവ് എക്സാമിനുമായിട്ട് കണക്ട് ചെയ്യുമ്പോൾ, പ്രത്യേകിച്ച് JEE മെയിൻ ആൻഡ് അഡ്വാൻസ്ഡുമായിട്ട് കണക്ട് ചെയ്യുമ്പോൾ ഈ ഗ്രാഫിന് വളരെയധികം ഇമ്പോർട്ടൻസ് ഉള്ളതാണ്. കഴിഞ്ഞ JEE മെയിൻസിൻ്റെ ക്വസ്റ്റ്യൻ നിങ്ങൾ നോക്കിയാൽ അറിയാൻ പറ്റും. ഗ്രാഫ് ട്രിഗണോമെട്രിക് ഫംഗ്ഷൻ്റെ ഗ്രാഫുമായിട്ട് കണക്ട് ചെയ്തിട്ട് അവിടെ പ്രോബ്ലം ഉണ്ടായിരുന്നു. അപ്പോൾ ഇവിടെ ഫംഗ്ഷൻസിലും നമ്മൾ ക്ലാസിഫൈ ചെയ്യുന്നു ആൾജിബ്രൈക് ഫംഗ്ഷനും ട്രാൻസെൻഡൻ്റൽ ഫംഗ്ഷനുമായിട്ട്. ഓക്കെ, അപ്പോൾ ഇതിൽ ഈ ആൾജിബ്രൈക് ഫംഗ്ഷനിൽ വരുന്നതാണ് പോളിനോമിയൽ ഫംഗ്ഷൻ. ആൾജിബ്രൈക് ഫംഗ്ഷൻ ഈസ് അഗെയിൻ ക്ലാസിഫൈഡ് ഇൻറ്റു പോളിനോമിയൽ ഫംഗ്ഷൻ. Algebraic function. This algebraic function is again classified into, first one is polynomial function. Okay, polynomial function, then rational function, then irrational function, and last one is piecewise function. Okay, then this piecewise function contains modulus. We know that what is modulus function, then signum function, then greatest integer function, then fractional part function, least integer functions. Okay, ഇതാണ് ഫംഗ്ഷനും ആൾജിബ്രൈക് ഫംഗ്ഷനും അതിൻ്റെ ക്ലാസിഫിക്കേഷനും. അതേപോലെ തന്നെ അതിൽ പീസ് വൈസ് ഫംഗ്ഷൻ, അത് അറിയാലോ, പീസ് വൈസ് എന്ന് പറയുമ്പോൾ ഗ്രാഫിന് ബ്രേക്ക് വരുന്നിട്ട് ഉള്ള ഫംഗ്ഷൻസാണ്. എഗെയിൻ അടുത്ത ആൾജിബ്രൈക് മാറ്റിയാൽ അടുത്തത് ട്രാൻസെൻഡൻ്റൽ ഫംഗ്ഷനാണ്. ഓക്കെ, സോ അതിനകത്താണ് നമ്മുടെ ട്രിഗണോമെട്രിക് ട്രാൻസെൻഡൻ്റൽ ഫംഗ്ഷൻ. ഇതിലാണ് നമുക്ക് ട്രിഗണോമെട്രിക് ഫംഗ്ഷൻ വരുന്നത്. ട്രിഗണോമെട്രിക് ഫംഗ്ഷൻ, ദെൻ എക്സ്പൊണൻഷ്യൽ ഫംഗ്ഷൻ, അതിൻ്റെ ഇൻവേഴ്സായ ലോഗരിതമിക് ഫംഗ്ഷൻ, ഇൻവേഴ്സ് ഓഫ് എക്സ്പൊണൻഷ്യൽ, ദെൻ ജോമെട്രിക്കൽ കർവ്, ആൻഡ് then inverse trigonometrical curve. സോ ഇതാണ് നമ്മുടെ ഈ ടൈപ്പ് ഫംഗ്ഷൻസ് എല്ലാം. ഈ ഫംഗ്ഷനും ഇതിൻ്റെ ഗ്രാഫും ഇതിൻ്റെ ഡൊമൈൻ, ഇതിൻ്റെ റേഞ്ച്, ഇതിൻ്റെ ഗ്രാഫിൻ്റെ പ്രോപ്പർട്ടീസ്, ഇതെല്ലാം നമ്മൾ ഈ ഒരു ഗ്രാഫിൽ ഈ ഒരു വീഡിയോയിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നതാണ്. ഓക്കെ, ഓരോന്നായിട്ട് 1 by 1 ആയിട്ട് നമുക്ക് നോക്കാം. ആദ്യത്തെ ആൾജിബ്രൈക് ആണ്, ദെൻ പോളിനോമിയൽ തന്നെ നമുക്കറിയാം. അത് ആ സമയത്ത് ഞാൻ പറയാം, ഡീറ്റെയിൽഡ് ആയിട്ട് പറയാം. ഇപ്പോൾ ഇവിടെ ഒരു ജസ്റ്റ് ഒരു ക്ലാസിഫിക്കേഷൻ മാത്രമേ പറയുന്നുള്ളൂ. ആ സമയത്ത് പോളിനോമിയൽ വരുന്ന സമയത്ത് നമുക്ക് ഏതൊക്കെ പോളിനോമിയലാണ്, അതിൻ്റെ ഗ്രാഫിക്കൽ റെപ്രസെൻറ്റേഷൻ എങ്ങനെയാണെന്നൊക്കെ നമുക്ക് ആ സമയത്ത് ഡിസ്കസ് ചെയ്യാം. ഓക്കെ, സോ വെൽക്കം ഓൾ അഗെയിൻ. നമുക്ക് ഫസ്റ്റ് ആൾജിബ്രൈക് ഫംഗ്ഷൻസ്. ഓക്കെ, ഫസ്റ്റ് വൺ ഈസ് ആൾജിബ്രൈക് ഫംഗ്ഷൻസ്. ഇപ്പോൾ ഈ ആൾജിബ്രൈക് ഫംഗ്ഷൻസിൽ എന്തൊക്കെയാണ് എന്നുള്ളത് നമ്മളവിടെ ഈ ക്ലാസിഫിക്കേഷനിൽ കണ്ടതാണ്. ഫസ്റ്റ് വൺ ഈസ് പോളിനോമിയൽ ഫംഗ്ഷനാണ്. ആൾജിബ്രൈക് ഫംഗ്ഷനിൽ ആദ്യത്തത് പോളിനോമിയൽ ഫംഗ്ഷനാണ്. അപ്പോൾ ഈ പോളിനോമിയൽ ഫംഗ്ഷനിൽ നമുക്ക് കുറച്ച് പോളിനോമിയൽ ഫംഗ്ഷൻ നമുക്കറിയാം. f(x) = x ഐഡന്റിറ്റി, f(x) = x², x³, then x⁴, x⁵, ഇതിങ്ങനെ വന്നു കഴിഞ്ഞാൽ അതിൻ്റെ ഗ്രാഫ് എങ്ങനെയാണ്, അതിൻ്റെ ഡൊമൈനും റേഞ്ചും എങ്ങനെയാണ് എന്നുള്ളതിനെ കുറിച്ചുള്ളൊരു ഡിസ്കഷൻ നമുക്കിപ്പോൾ നോക്കാം. ദെൻ പോളിനോമിയൽ കഴിഞ്ഞിട്ട് നമുക്ക് റാഷണൽ ഫംഗ്ഷനും ഇറാഷണൽ ഫംഗ്ഷനിലേക്കൊക്കെ പോകാം. ഓക്കെ, സി എ ഫംഗ്ഷൻ ഓഫ് ദ ഫോം f(x) = a0 plus a1x plus a2x² plus etc. plus an x⁻n, where the small n belongs to set of natural numbers and these constants a0, a1, etc. an belongs to set of real numbers. Then f is called a polynomial function. Okay, then f is called a polynomial function. So this is a polynomial function. Okay. Now we can discuss some basic polynomial function. First one is the identity function. Okay. Identity function f of x is equal to x. For every x belongs to set of real numbers is called the identity function. So this identity, the graph of this identity function, identity function is a straight line. This is a straight line which makes an angle 45 degree with the positive direction of x-axis as shown in the graph. See, f of x is equal to x. F of x is equal to x, y is equal to x denote cheyanu. Y is equal to x is a straight line. Straight line makes an angle 45 degree with positive direction of x-axis. Domain of this function is the set of real numbers, and range of this function is also set of real numbers. Okay, so that is the first one, identity function f of x is equal to x. Okay. Now the second one is f of x is equal to x square is called the square function. Okay. Square function. The domain of this square function is equal to set of real numbers, and range of this square function is positive real numbers union set 0, or it can be written as left closed 0, right open infinity. Okay, so the graph, see this graph, f of x is equal to x square. This is y is equal to, this f of x is equal to x square is also can be written as y is equal to x square. Y is equal to x square is a parabola. Y is equal to x square is a parabola. Y is equal to x square is an even function. See, when x is replaced by negative f of negative x is equal to negative x the whole square, which is equal to x square. It's an even function. The graph is symmetrical about y-axis. Okay, y-axis symmetric aanu. See this graph, f of x is equal to x square. Okay. Now the third graph is f of x is equal to x cube is the third graph. This is called the cube function. Okay, the domain of this cube function is set of real numbers, and range of this cube function is also set of real numbers. Now since f of x is equal to x cube or y is equal to x cube is an odd function. Okay, that is if f of x is equal to x cube, f of negative x is equal to negative x the whole cube, that is negative x cube, which is negative of f of x. So this is an odd function. So its graph is symmetrical about opposite quadrant. Its graph is symmetrical about opposite quadrant. So you can see this graph opposite quadrant, that is first part is in this first quadrant. With respect to this origin, these two graphs are in opposite quadrant. Okay, so the graph is symmetrical about opposite quadrant. Okay. Now the fourth type is f of x is equal to x raised to 2n, where n belongs to n. Since this n belongs to n, f of x is equal to x raised to 2n, but is f of negative x. F of negative x is negative x the whole raised to 2n, that is equal to negative x square the whole raised to n, that is x raised to 2n, which is equal to f of x. So this x raised to 2n is an even function. Therefore, f of x is an even function. So what about this graph of this even function? This graph of this even function is symmetrical about y-axis. Therefore, graph of f of x is symmetrical about y-axis. Okay. Now we can discuss what is f of x is equal to x square, then x raised to 4, x raised to 6, x raised to 8. ഇതെല്ലാം നമുക്ക് ഒരു ഗ്രാഫിക്കൽ റെപ്രസെൻറ്റേഷൻ ആയിട്ട് നമുക്ക് നോക്കാം. അത് ആ ഗ്രാഫിൻ്റെ വാല്യൂസ് അത് എങ്ങനെയാണെന്ന് കൂടി ഒന്ന് ഡിസ്കസ് ചെയ്യാം. ഓക്കെ. Now see the graph of f of x is equal to x square. Okay. f of x is equal to x square. ഇവിടെ നമുക്ക് ഈ -1 ഓപ്പൺ ഇൻ്റർവൽ ഓപ്പൺ ഇൻ്റർവൽ -1 ൽ ഫംഗ്ഷൻ്റെ വാല്യൂ ഇതാ ഇവിടെയാണ് -1 and 1. ഇൻ ബിറ്റ്വീൻ -1 and 1 ആ ഒരു റീജിയണിൽ ഫംഗ്ഷൻ്റെ വാല്യൂ നോക്കുക. ദാറ്റ് ഇസ് എ പരാബോള. f of x is equal to x square. Now f of x is equal to x raised to 4. നോക്കൂ, f of x is equal to x raised to 4 is the second curve. f of x equal to x square is the red curve. Then f of x is equal to x raised to 4 is the green curve. Okay. So all these values, when x belongs to this open interval -1, 1, x belongs to in between -1, 1, all the value of this f of x is equal to x raised to 4 is less than that of x square. But x square നേക്കാൾ ചെറിയ values ആണ് x raised to 4 ന് വരുന്നത്. Okay. Now what about x raised to 6? x raised to 6 ആകുമ്പോൾ വീണ്ടും വാല്യൂ ഡിക്രീസ് ചെയ്യും. ഓക്കെ. x raised to 6ൻ്റെ വാല്യൂ x raised to 2വിനേക്കാൾ വാല്യൂ ലെസ് ആണ് ഇൻ ബിറ്റ്വീൻ -1 and 1. ആ ഒരു ഇൻ്റർവെൽ നോക്കുക, ഇൻ ബിറ്റ്വീൻ -1 and 1. Then what about x raised to 8? Again decreases, x raised to 8. So x raised to 8 has the least value in between. x raised to 8 ഇനി x raised to 10 വന്നു കഴിഞ്ഞാൽ വീണ്ടും കുറയും. x raised to 10 വന്നു കഴിഞ്ഞാൽ വീണ്ടും ഡിക്രീസ് ചെയ്യുന്നതായിട്ട് കാണാൻ പറ്റും. So x raised to 8 then increases x raised to 6, then x raised to 4, then x raised to 2. So therefore we can say that x square greater than x raised to 4 greater than x raised to 6 greater than x raised to 8, okay, greater than etc. For all x belongs to -1, 1. Okay. Now what about without in -1, 1 ഒഴികെയായിട്ടുള്ളത്? Okay, if we delete -1, 1 from the set of real numbers, what is the value of this graph? അപ്പോൾ ഇതിൻ്റെ ഗ്രാഫിൻ്റെ വാല്യൂ എങ്ങനെയാണെന്ന് നമുക്ക് നോക്കാം. See the graph f of x is equal to x square ആണ് നമ്മൾ നേരത്തെ കൺസിഡർ ചെയ്തത്. ഇൻ ബിറ്റ്വീൻ -1 and 1 ആണ് കൺസിഡർ ചെയ്തത്. ഇനി -1, 1 ഒഴികെ, ദാറ്റ് ഈസ് 1 ഇൻഫിനിറ്റി ഗ്രേറ്റർ ദാൻ 1 ആൻഡ് ലെസ് ദാൻ -1, അവിടെ ഗ്രാഫ് എങ്ങനെയാണെന്ന് നമുക്ക് നോക്കാം. f of x is equal to x square ആണ്. ബട്ട് അബൌട്ട് x raised to 4 നോക്കൂ. x raised to 4 വരുമ്പോൾ ഇൻ ലെസ് ദാൻ ദാറ്റ് ഓഫ് -1 ആകുമ്പോൾ, ലെസ് ദാൻ -1 ആകുമ്പോൾ x raised to 4 has the greatest value. ഓക്കെ. ഈ -1ന് ലെഫ്റ്റ് സൈഡ് വരുമ്പോൾ, ഇനി 1ൻ്റെ റൈറ്റ് സൈഡിൽ വരുമ്പോഴും x raised to 4 is green curve. Green curve is f of x is equal to x raised to 4, which has the larger value that of x square. Now what about x raised to 6? See, x raised to 6 is the blue curve. അത് x raised to 4നേക്കാൾ larger values ആണ്. x raised to 6 in. No. What about x raised to 8? X raised to 8 is the pink curve. So its value is greater than that of x raised to 6. Okay. So x raised to 6 ഇവിടെ ഇപ്പോൾ നമ്മളിപ്പോൾ കാണുന്നതിൽ x raised to 8 നാണ് larger value, that is less than, a blue curve is less than that of x raised to 8, that is x raised to 6 is less than that of x raised to 8, again less than x raised to 4 നെ മറ്റ് രണ്ട് കർവിനേക്കാൾ താഴെയാണ് x raised to 4 ന്റെ വാല്യൂ. ഓക്കെ, ദെൻ എക്സ് സ്ക്വയർ. അപ്പോൾ എക്സ് സ്ക്വയറിന് സി ദിസ് ഗ്രാഫ് ഉണ്ടോ? So x square has the least value. Therefore x square less than x raised to 4 less than x raised to 6 less than x raised to 8. നമ്മൾ ഈ -1 1ൽ കണ്ടതിൻ്റെ നേരെ റിവേഴ്സ് ആയിരിക്കും ലെസ് ദാൻ -1 ആൻഡ് ഗ്രേറ്റർ ദാൻ 1ൽ ഈ കർവിൻ്റെ പ്രോപ്പർട്ടി എന്ന് പറയുന്നത്. ഓക്കെ, therefore x square less than x raised to 4 less than x raised to 6 less than x raised to 8 less than etc. for all x belongs to -infinity -1 union 1 infinity. Okay, now the next function is equal to f of x is equal to x raised to 2n minus 1, n belongs to n. Okay, f of negative x is equal to negative x the whole raised to 2n minus 1 f of minus f of x, comma an odd function. Can be seen that it is an odd function. Therefore its graph is symmetrical about opposite quadrant. Symmetrical about opposite quadrant. Okay, now we can draw some graph. That is f of x is equal to x cube, x raised to 5, x raised to 7. Okay, now consider the graph of f of x is equal to x. See this graph, f of x is equal to x, that is the identity function. X ന്റെ power 1 ആണ്, odd number. Now f of x is equal to x cube. That is these graphs are symmetrical about opposite quadrant. Now f of x is equal to x raised to 5, that is the blue curve, and f of x is equal to x raised to 7, that is the pink curve. Okay, അപ്പോൾ നമ്മളിവിടെ ഇതിലെ ഈ ഗ്രാഫിൻ്റെ വാല്യൂസ് നമ്മളൊരു 4 ഇൻ്റർവെലായിട്ട് റിയൽ ലൈനിൻ്റെ 4 ഇൻ്റർവെലായിട്ട് സ്പ്ലിറ്റ് ചെയ്യുന്നത്. ദാറ്റ് ഈസ് -infinity to -1 ഇവിടം വരെ. ഇവിടെ ഈ പോയിന്റിൽ that is -infinity to less than -1 and -1 in between -1 and 0, then in between 0 and 1, then greater than 1, that is 1 infinity. ഇങ്ങനെ 4 റിയൽ ലൈനിലെ 4 ഇൻ്റർവെലായിട്ട് സ്പ്ലിറ്റ് ചെയ്തിട്ട് ഈ 4 ഇൻ്റർവെല്ലിലും ഈ കർവിൻ്റെ വാല്യൂസ് എവിടെയാണ് കൂടുതൽ എവിടെയാണ് കുറവെന്നുള്ളത്, ഏത് കർവിനാണ് വാല്യൂ കൂടുതൽ അല്ലെങ്കിൽ ഏത് ഫംഗ്ഷനാണ് വാല്യൂ കൂടുതൽ എന്ന് ചെക്ക് ചെയ്യാം. So first consider the interval -infinity to -1. When x belongs to -infinity -1. Okay, x belongs to -infinity -1. ഈ ഗ്രാഫിൽ ഫംഗ്ഷൻ്റെ വാല്യൂ in between -infinity and -1. See, this is the okay. So in between -infinity, that is less than -1, which curve has the greatest value? So in between -infinity and or less than -1, f of x is equal to x has the greatest value. Okay, then f of x is equal to x cube has the value less than that of f of x is equal to x, then again less than f of x is equal to x raised to 5, then x raised to 7. X raised to 7 is the pink shaded or pink curve. So x greater than x cube greater than x raised to 5 greater than x raised to 7 greater than etc. X belongs to minus infinity minus 1. Now when x belongs to minus 1 0, when x belongs to minus 1 0, that is in between minus 1 and 0, which curve has the greatest value? Minus 1 0, x raised to 7 has the greatest value. Okay, then x raised to 5 has the value less than that of x raised to 7, then x raised to 3, then x. So when x belongs to minus 1 0, x has the least value. F of x is equal to x has the least value. So x is less than x cube less than x raised to 5 less than x raised to 7 less than etc. X belongs to minus 1 0. Now when x belongs to 0 1, when x belongs to 0 1, what about when x belongs to 0 1? That is in between 0 and 1, f of x is equal to x has the greatest value, then again x cube, then x raised to 5, then x raised to 7. So x belongs to 0 1, x has the greatest value. So x greater than x cube greater than x raised to 5 greater than x raised to 7 greater than etc. Now when x belongs to 1 infinity, x belongs to 1 infinity, okay, x belongs to 1 infinity, that is greater than 1. When x belongs to 1 infinity, x raised to 7 has the greatest value and x has the least value. Okay, so x less than, x has the least value means x is less than x cube less than x raised to 5 less than x raised to 7 less than etc. So that is the graph of f of x is equal to x raised to 2n minus 1. The power is an odd integer. Okay, next is rational function. See, a function obtained by dividing a polynomial by another polynomial is called a rational function. That is, f of x is equal to p of x by q of x. Now domain of this rational function is equal to real number set minus set of real numbers minus set of all x such that q of x is equal to 0. Okay, now we can discuss some simple rational function. First one is f of x is equal to 1 by x, is called a reciprocal function. Reciprocal function, reciprocal function or rectangular hyperbola, or rectangular hyperbola. Okay, that is f of x is equal to 1 by x, and the domain and range of this function, domain of this function is equal to r minus set 0, and range of this function is also r minus set 0. Okay, see this graph, f of x is equal to 1 by x. The graph of this function is here. This graph is symmetrical about opposite quadrant. F of x is an odd function. F of x is an odd function. Therefore, f of x is graph is symmetrical about opposite quadrant. Symmetrical about opposite quadrant. Okay, quadrant. See this graph, f of x is equal to 1 by x, symmetrical about opposite quadrant. symmetrical about opposite quadrant. Okay. Now limit x tends to 0 plus f of x. Limit x tends to 0 plus f of x is equal to plus infinity. Okay, when x tends to 0 plus, when x is approaching to the right side of this origin, the value of the function tends to infinity. Okay, this will tends to infinity. When x is approaching to the right side of, x is approaching to 0 to the right hand side of this 0, the value of this function become infinity, that is tends to infinity. Okay, f of x, limit x tends to 0 plus f of x, and limit x tends to limit x tends to 0 minus f of x is equal to minus infinity now. Okay, ഇത് ലെഫ്റ്റ് സൈഡിലൂടെ സീറോയിലേക്ക് അപ്രോച്ച് ചെയ്താൽ the value of the function tends to negative infinity. Okay, now x tends to infinity. When x tends to infinity, limit x tends to infinity f of x, the function value of the function tends to, when x tends to infinity, the value of the function that is the curve approaching to the x-axis, not touching the x-axis, that is approaching to the x-axis. When x tends to infinity, when x increases, the function become very close to x-axis. Okay, that is the value of the function, limit of the function is equal to 0. Also limit x tends to minus infinity, x tends to minus infinity f of x is equal to, that is x tends to negative infinity. See, when x tends to negative infinity, x is very small. Okay, when x tends to negative infinity, the curve become very close to negative x-axis, means the value of the function tends to 0. Okay, so when x tends to negative infinity, f of x tends to 0, or value of the limit is equal to 0. Okay, so this is the graph of f of x is equal to 1 by x. Now consider the rational function f of x is equal to 1 by x square, which is an even function. So its graph is symmetrical about y-axis. Graph is symmetrical about y-axis. Okay, symmetrical about y-axis. It's an even function. Domain of this function, domain of f is equal to set of real numbers minus non-zero real numbers, and range of f is equal to open interval 0 infinity. Okay, now limit x tends to 0 plus f of x, limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x, 0 minus f of x is equal to infinity, or the value of the function tends to infinity, or limit of that function is equal to infinity. Now limit x tends to infinity, f of x, that is plus infinity or minus infinity. Limit x tends to plus infinity is equal to 0, that is when x increases, that is when x tends to infinity, the graph or the curve tends to, or the value of this function tends to 0, or the curve approaching to the x-axis. So limit of this function is 0. Now when x tends to minus infinity, x negative infinity like tend ചെയ്ത് കഴിഞ്ഞാലും ഗ്രാഫ് എക്സ് ആക്സിലേക്ക് മൂവ് ചെയ്യുന്നതായിട്ട് എക്സ് ആക്സിനോട് വളരെ അടുക്കുന്നതായിട്ട് കാണാൻ പറ്റും. So limit x tends to minus infinity, f of x is also 0. Okay, so that is f of x is equal to 1 by x square. Okay. Now see the third one, f of x is equal to 1 by x raised to 2n minus 1. 2n minus 1 is an odd number. For example, f of x is equal to 1 by x, or f of x is equal to 1 by x cube, f of x is equal to 1 by x raised to 5, f of x is equal to 1 by x raised to 7, etc. Now see, f of x is equal to 1 by x. That is the reciprocal function that we have already discussed. F of x is equal to 1 by x. Okay. Now f of x is equal to 1 by x cube. 1 by x cube is the second function. Now f of x is equal to 1 by x raised to 5. That is the red curve. Okay. See, these curves are symmetrical in opposite quadrant. The graph is symmetrical in opposite quadrant. Symmetrical in opposite quadrant. Opposite quadrant. Okay. Okay. Now limit x tends to 0 plus f of x. Limit x tends to 0 plus f of x is equal to, limit x tends to 0 plus f of x is equal to, see, when x is approaching to 0, to the right side of 0, the value of the function tends to infinity. So its limit is, its limit is infinity. Okay. Now limit x tends to 0 minus, x tends to 0 minus f of x is equal to, when x tends to 0 minus, that is x is approaching to 0 to the left side of 0, the value of the function tends to negative infinity. Okay, so limit is equal to minus infinity. Now the x-axis, that is symmetric, this curve is symmetric about in opposite quadrant. The y-axis, see this positive x-axis and positive y-axis. Positive x-axis and positive y-axis is the asymptote of this curve. Okay, that is the tangent. These axes become the tangent at infinity. So coordinate axis for f of x is equal to 1 by x. F of x is equal to 1 by x. Asymptotes as the coordinate axis. So for this curve, f of x is equal to 1 by x, f of x is equal to 1 by x cube, f of x is equal to 1 by x raised to 5. This curve has asymptotes as coordinate axis. See, this curve, f of x is equal to 1 by x, f of x is equal to 1 by x cube, f of x is equal to 1 by x raised to 5. Coordinate axis means positive x-axis and positive y-axis. So in the first quadrant, these two axes as the asymptote of this curve. Now for the curve lies in third quadrant, negative x-axis and negative y-axis are the asymptote of this curve. Okay. Now the fourth one, f of x is equal to 1 by x raised to 2n, where n belongs to n. This is an even function. even function. Okay, that is symmetrical about, therefore graph is symmetrical about, graph is symmetrical about y axis. That is f of x is equal to 1 by x square. See this graph, that is symmetrical about y axis. Now f of x is equal to 1 by x raised to 4. See this graph, that is also symmetrical about y axis. Next is f of x is equal to 1 by x raised to 6. That is also symmetrical about y axis. Okay. Now limit x tends to 0, limit x tends to 0 plus f of x. When x is approaching to 0 to the right side of 0, the value of the function tends to infinity. So limit is equal to infinity. Okay. Now limit x tends to 0 minus f of x, which is also infinity. Okay. Now limit x tends to minus infinity f of x. When x is approaching to negative infinity, all these curves approaching to the x-axis means the value of the function tends to 0. So the limit is equal to 0. Also when limit x tends to infinity plus infinity f of x, that is when x tends to infinity, that is when x is approaching to, x is very large, the curve is approaching to the x-axis. Limit x tends to infinity f of x is also 0. Okay. Now the third one is irrational function. The algebraic function containing terms having non-integral rational powers of x are called irrational function. Okay. For example, see the first one, graph of f of x is equal to root x or x raised to 1 by 2. Here the power is a non-integral rational power, that is 1 by 2. Okay. So this is the graph of f of x is equal to root x. Okay. This f of x is equal to root x is the portion of the parabola y square is equal to x. See this graph, y square is equal to x is this parabola. F of x is equal to root x is the upper part of this y square is equal to 4x. Okay. So f of x is equal to x raised to half is the portion of the parabola y square equal to x lies above the x-axis. Okay. Now domain of this function is domain of f is equal to positive real number union set 0 or left closed 0 right open infinity. Okay. Now range of this function, range of f is equal to r plus union set 0 or left closed 0 right open infinity. Okay. Now if you draw this line f of x is equal to x, this is the line, this green line is the straight line f of x is equal to x. So intersect at 2 points. First one is the origin and second one is this point ordered pair 1 1. Okay. So that is the first irrational function. Okay. Now consider the irrational function f of x is equal to x raised to 1 by 3. The graph is here. F of x is equal to x raised to 1 by 3. Now consider the function another function g of x is equal to x cube. Okay, see this function. See this function, that is the red curve. G of x is equal to x cube. We can see that this g of x is the image, or f of x is the image of g of x with respect to this line y is equal to x. See, this y is equal to x is the green line. F of x is equal to x raised to 1 by 3 is this line, this curve. So that curve is the mirror image of g of x is equal to x cube. Okay, then f of x is equal to f of x is the image of g of x about the line y is equal to x. Domain of f is the set of real numbers, and range of f is also the set of real numbers. Okay, so this is the graph. See, this is the graph. F of x is equal to x raised to 1 by 3, and we draw the line y is equal to x. With respect to this line y is equal to x, we draw the image, that is, see, the image of this portion or this curve is here, the red line. Okay, image of this one is the red line. Okay, so f of x is equal to x cube is the, or f of x is equal to x raised to 1 by 3 is the image of g of x is equal to x cube. Okay, now consider the third irrational functions of the form f of x is equal to x raised to 1 by even number, that is f of x is equal to x raised to 1 by 2. See this graph, f of x is equal to x raised to 1 by 4, x raised to 1 by 6, x raised to 1 by 8, etc. Now consider f of x is equal to x raised to 1 by 2. See this graph, the graph of f of x is equal to root x is here. Now consider another one, g of x is equal to x raised to 2. G of x is equal to x raised to 2. Here is the graph. So this graph is g of x is equal to x square is the mirror image of, with respect to this line, y is equal to x. ഇത് പരസ്പരം mirror image ആയിട്ട് വരും. f of x is equal to x raised to 1 by 2 and g of x is equal to x square. Okay. Now f of x is equal to 1 by 4. F of x is equal to 1 by 4 is this graph. F of x is equal to 1 by 4. F of x is equal to, not 1 by 4. F of x is equal to x raised to 1 by 4. Now consider another curve or another function f of x, g of x is equal to x raised to 4. See, this is g of x is equal to x raised to 4. These two curve is symmetric, or these two curve is, first curve f of x is equal to x raised to 1 by 4 is the mirror image with respect to this line y is equal to x. F of x is equal to x raised to 1 by 4 and g of x is equal to x raised to 4. Okay. Now what about f of x is equal to x raised to 1 by 6? X raised to 1 by 6. See this graph. F of x is equal to x raised to 1 by 6. Now g of x is equal to x raised to 6. See, g of x equal to x raised to 6 ആണ്. ഇത് നമുക്ക് കാണാൻ പറ്റും y is equal to x നെ ബേസ് ചെയ്തിട്ട് ഇത് സിമെട്രിക് ആണെന്ന് കാണാൻ പറ്റും. Okay, so these are the curve. First one we discussed, first one x raised to 1 by 2 and then x raised to 1 by 4, then x raised to 1 by 6. Now another g of x is x square, g of x is x raised to 4, then x raised to 6. Okay, so this is the irrational function f of x is equal to x raised to 1 by 2n. Okay, so this x raised to 1 by 2n is the mirror image of f of x is equal to x raised to 1 by 2n is the mirror image of g of x is equal to x raised to 2n. Okay. About the line, or with respect to about the line, y is equal to x. Okay, where x belongs to, see, where x belongs to 0, infinity, not in the second or third or fourth quadrant, we consider only the first quadrant. Okay. Now what is the domain and range of f of x? See, this domain of f is left closed 0, right open infinity, and range of f is also left closed 0, right open infinity. Okay. Now the fourth one, f of x is equal to x raised to 1 by odd number, 1 by 2n minus 1, where n belongs to n. Here f of x is equal to, this function is defined for all x belongs to R. f of x is defined for all x belongs to set of real numbers. So domain of this function is the set of real numbers, and range of f is also set of real numbers. And the graph of this function f of x is equal to 1 by x raised to 2n minus 1. See, 1 by x raised to 2n minus 1, we can consider f of x is equal to x raised to 1 by 3, x raised to 1 by 3, or f of x is equal to x raised to 1 by 5, or f of x is equal to x raised to 1 by 7, etc. Okay. Now f of x is equal to 1 by x cube, x raised to 1 by 3. X raised to 1 by 3 is here. This is the graph. F of x is equal to x raised to 1 by 3. Now consider the function g of x is equal to x cube. What is g of x is equal to x cube? See this graph. G of x is equal to x cube. What about this graph? This graph is g of x is equal to x cube is the mirror image of the function f of x is equal to x raised to 1 by 3 with respect to this line y is equal to x. Okay. Now second one function f of x is equal to x raised to 1 by 5. This is the graph. F of x is equal to x raised to 1 by 5. Now consider g of x is equal to x raised to 5. What is x raised to 5? This is the graph, x raised to 5. What is the speciality of this graph? This graph is, that is, g of x is equal to x raised to 5. That the graph we have drawn in the second time. X raised to 5 is the mirror image of f of x is equal to x, or y is equal to x. With respect to this line, y is equal to x. This is the mirror image. Okay. Now consider another one, g of x is equal to x raised to 7. G of x is equal to x raised to 7. So consider this function f of g of x. F of x is equal to x raised to 1 by 7. This is x raised to 1 by 7. Now x raised to 7 is this graph. So this graph is the mirror image with respect to this line y is equal to x. Okay. So we can see that. So this is x raised to 1 by 3. Mirror image is x raised to 3. Now x raised to 1 by 5. Mirror image is x raised to 5. So in general case, we can see that the f of x is equal to graph of f of x equal to x raised to 1 by 2n minus 1 is the mirror image of the g of x is equal to x raised to 2n minus 1 about the line y is equal to x. Okay. So these are the functions, these are the irrational functions. ഓക്കെ. സോ ഇതാണ് നമ്മുടെ ഒന്നാമത്തെ വീഡിയോ ഇവിടെ കംപ്ലീറ്റ് ചെയ്യുവാണ്. അടുത്ത നമുക്ക് പീസ് വൈസ് ഫംഗ്ഷൻസ് ആണ്. ആ പീസ് വൈസ് ഫംഗ്ഷൻസിൽ നമുക്ക് ഡിസ്കസ് ചെയ്യേണ്ടത് മോഡുലസ് ഫംഗ്ഷൻ ഉണ്ട്, സിഗ്നം ഫംഗ്ഷൻ ഉണ്ട്, ഗ്രേറ്റസ്റ്റ് ഇൻറ്റിജർ ഫംഗ്ഷൻ, ഫ്രാക്ഷണൽ പാർട്ട് ഫംഗ്ഷൻ ആൻഡ് ലീസ്റ്റ് ഇൻറ്റിജർ ഫംഗ്ഷൻ. അതൊരൊറ്റ വീഡിയോ ആയിട്ട് നമുക്ക് അടുത്തതായിട്ട് ചെയ്യാം. ഓക്കെ, താങ്ക് യു.